And so our next speaker is Tahseen Shabab. Tahseen is the co-founder and the CEO of Penfield.AI, pioneering human-machine intelligence in cybersecurity. Before Penfield.AI, Tahseen was a cybersecurity consultant for firms like IBM, top Canadian bank, Fortune 60 telco, a North American government, and more. And Tahseen was also the lead developer for AppScan Source on Cloud, a cloud security solution used by many Fortune 500 firms. And Tahseen graduated from the University of Waterloo Electrical Engineering. And Tahseen will talk about continuously improving the capability of human defenders and with AI. All right, so Tahseen, all yours.
Wonderful, Brian. Thank you so much for the warm introduction. It's always a pleasure to be part of your conference. So, folks, thank you for joining this session. So our topic, the topic of today's discussion is how to continuously improve the capability of human defenders with AI. Before I kick things off, I would like to thank the Microsoft team for their excellent presentation and for highlighting the importance of human-machine intelligence in cybersecurity. It's a paradigm shift where the objective of AI is not to replace humans, but rather the objective of AI is to collaborate with humans to collectively solve a problem more effectively. So I'll move on to the next slide. And I must admit, it's such an exciting time to be in cybersecurity and artificial intelligence. We're living through a truly remarkable time. Microsoft just upped their stake in OpenAI, the firm behind ChatGPT. Google is also trying to launch their chatbot, and investors are curious about which tech titan will win the AI race. While Google was previously viewed as a leader, ChatGPT has captured attention, and Microsoft planned to incorporate the technology with its offerings. At the 2023 World Economic Forum annual meeting in Switzerland, Microsoft CEO Satya Nadella announced plans to incorporate ChatGPT AI tools into all Microsoft products. The advanced language capabilities would enable users to generate text, write emails, create presentations with more personalization, and more. The move demonstrates Microsoft's commitment to the future of AI and utilizing ChatGPT-style tools in its flagship products. However, the easy access to advanced AI also means malicious actors can use it for their own purpose. Researchers have observed an increase in sophisticated attacks using ChatGPT-like AI, which we will call large language models, or LLM. And these attacks include the things such as phishing incidents, as well as polymorphic malware, and more such attacks are expected to follow. And we'll briefly touch on these forms of attacks in the coming slides. So large language models like ChatGPT can be used by cyber criminals to create sophisticated phishing emails that imitate the human language and automate the entire process, leading to an increase in successful attacks. This could result in significant financial loss and harm to the reputation of individuals as well as organizations. In a test, ChatGPT was asked to write a persuasive email for a wire transfer to a supplier, resulting in a more sophisticated email than most real attacks, including a convincing story with empathy written without any grammatical errors. And an example of this has been showcased on the left-hand side. Furthermore, ChatGPT could have the unintended consequence of providing feedback to malicious actors, enabling them to learn from successful phishing attacks and to craft even more sophisticated emails. An experiment asked ChatGPT to generate an email with high chance of getting the recipient to click a link, resulting in a message similar to many credential phishing emails. When asked about its reasoning, ChatGPT returned a lengthy response explaining the social engineering principles behind the email's effectiveness. And as you can imagine, this would be a great tool for hackers to quickly upskill their capabilities to bypass our defenses. Next, we'll focus our attention on polymorphic malware. Polymorphic malware is a type of malicious software designed to evade detection by changing its code or appearance every time it infects a new system. The malware's ability to mutate makes it more difficult for security systems to detect them. Polymorphic malware can be used for various malicious purposes, such as stealing sensitive data, compromising systems, or causing damage to computer networks. It is a type of advanced malware that requires more sophisticated methods for detection as well as removal. As depicted on the left, researchers were able to bypass ChatGPT's content filter, which prevents tools such as ChatGPT to share these insights to the wrong folks. And by doing so, researchers were able to force ChatGPT to create a basic DLL injection script into Explorer. Additionally, ChatGPT's ability to continually mutate injectors can produce a polymorphic program that is evasive and hard to detect. A sample of a mutated code has been shown on the right. So at a high level, the idea here is you can bypass ChatGPT's content filter to first generate such malicious code. And furthermore, we can continuously prompt ChatGPT to change the code whenever required, making it even hard for our detection tools to detect such malware. However, that being said, our defenders are not sitting on the sidelines, and we've already started incorporating tools such as ChatGPT into our arsenal. I personally use ChatGPT every day for things such as my coding, research, sometimes even scripting and or proofreading emails and more. And I'll showcase some examples on how our defenders could use ChatGPT. Large language models like ChatGPT can be easily incorporated by cyber professionals with regular tasks, as demonstrated in the example on this slide. In the first example, ChatGPT provides specific instructions for a pen tester to search for SMB malware vulnerabilities using a tool called Nmap. This can get junior analysts up to speed and build their skills required to perform ethical hacking. In the next example, ChatGPT helps the blue team by writing KQL queries to search for failed login attempts for a specific user within the past 24 hours. Such queries can be used to create custom detection logic or for threat hunting. In other words, authoring such KQL queries are no longer a task for senior or experienced analysts. Rather, folks who are quite green can quickly get up to speed and prompt ChatGPT to help them write such code. It is important to note that many times ChatGPT could be wrong. However, from my personal experience, it is quite easy to tweak the code to make it work for the purpose at hand. In addition, ChatGPT can also be used to automate simple commands, such as writing a bash script to automate a port scan using Nmap, as shown in this example. And of course, with more prompts, more sophisticated script could be authored. While this looks quite promising, it is important to note the drawbacks of large language models such as ChatGPT. Now, these tools are performant for a generic purpose tasks, and I'll share some insights as to why that is the case. That being said, for tasks which require context or domain experience, it has been noticed, and it is quite frequent to see these tools either hallucinating or they're not able to understand customer context. And I'll showcase a few slides to demonstrate these examples, followed by mechanisms to train these AI models to make them more performant on domain and context related tasks. Now, what makes cybersecurity unique is the emphasis on context. And here's an example. So within a bank, the same attack on your online banking server could be dealt with completely differently than that, say, of your reward server, due to things such as they could be on a different technology stacks, different business criticalities, different policies, and more. So the same attack is not being resolved exactly same for even different business units in the same organizations. Furthermore, for MSSP and MDRs, this problem is further aggravated as these organizations ingest data from different companies who could be using different technology stacks, could be different industries, could be experiencing different kinds of attacks, which makes it the context even more important to understand. Now, as I've mentioned, vanilla large language models or large language models which haven't been fine-tuned will not be able to understand customer context, and this makes sense. And here's one example. In this chat, ChatGPT was requested to write automation code to prevent phishing attacks on a specific bank. However, since the AI does not have sufficient information about the customer's processes, tools, and architecture, it cannot provide a performant solution, and it has to rely on generic information. This is because these models are trained with large sets of data from the internet. And these models are a jack of all trades, but a master of none. If you throw a domain or context-specific questions, you'll most likely get a generic or incorrect response. However, if the vanilla model was trained with more accurate historic data pertaining to specific clients or the domain, the tools such as ChatGPT can be extremely performant, and we'll discuss how this can be achieved in the coming slides. Next, we'll focus our attention on the notion of hallucination. So as I've mentioned many times, tools such as ChatGPT hallucinate. And on the left-hand side, we have a quote from the researchers at OpenAI, and I'll read it out. So OpenAI states that these models generate outputs that are sometimes untruthful, toxic, or reflect harmful sentiments. ChatGPT-3 is trained to predict the next word on a large data set from the internet rather than a language task on what the user wants. So at a high level, and I'll focus on the diagram on the right, these models, what they do is they're trained on large data sets, could be generic. And the objective of these models is to predict certain words which align with its data set. And here on the right hand side, we have a very simple example, but I wanted to showcase this chart. It illustrates how these models work at a high level. So in the large language models, the decoding is the process of generating output text from input text. So we give an input, and then it uses a thing called decoding to generate the output. But this is done by selecting the most likely sequence of words that the model predicts using a specific algorithm. So it doesn't always understand the context of the client, of the person sharing the input, but rather it's going to try to look for the data set which it was used to train, and then find a likely match. And as you can imagine, if the data does not have your customer context or your business context or your domain context, then you'll most likely not get the correct response. It is important to note that more sophisticated models such as ChatGPT-3 do and have some more enhanced logic to reduce repetitive responses and outputs, which just does not make sense. But that being said, this problem still persists in these models. And I'll touch on how human-machine intelligence can be used to address this problem. Now, I do understand the presenters at Microsoft did also coin this term, and a little bit of background. We started doing at Penfield.AI, we started doing research on the concept of human-machine intelligence in end of 2017 out of the University of Waterloo. And this was at a time when the whole promise was AI will automate everything. I still recall many of the SOAR vendors would mention, get humans out of the loop. And our research demonstrated that the optimal performance would be reached if humans and AI could collaborate together to address a problem. And that is the whole concept of human-machine intelligence. And using human-machine intelligence, I would like to touch on two use cases. The first use case is how do we build context-rich large language models with human-machine intelligence. So again, large language models are technologies such as ChatGPT. And in this example, we'll showcase the following. We'll take a vanilla large language model, could be a ChatGPT, which hasn't been fine-tuned. And then the whole objective here is, if we have a framework to enable these models to for us to train or fine-tune this already trained model with our customer or domain-centric data, we would be able to build highly performant models which can be used in our day-to-day work. And these things, these technologies could be used for things such as text generation, automated documentation, summarization, quality checks, as well as some of the use cases we have seen in the past. Based on research by OpenAI, I've shared a couple of things on the lower right corner. Weekly fine-tuning your models, even with a small amount of data, could lead to a 50% reduction in error rate. Now, the challenge in cybersecurity is the following. How do you get accurate customer data from your tools? Because our data is being generated by analysts with different kinds of capabilities who might not have their equal skill sets across different types of tasks. Furthermore, the client context is important as well. Not all of our analysts do have that knowledge. So in this ocean of data, how do you pick the right data which can be used to train these models? And I'll showcase how this can be done through human machine intelligence, where it's a form of intelligence system which looks at the incident data and the customer context. It also looks at the interaction data. What are the actions taken by your analyst across all of your tools to solve the problem? And based on that, we'll showcase how we can automate the quality assurance process to select high quality data, which can then be fed to these AI models on a weekly basis to train your model and get high performance. So this is use case one, which is how do we build context-rich large language models. And the second use case I would like to touch on is how do we feed accurate context data into these models to build a playbook. So for instance, as I've mentioned, vanilla large language models might not have the right context data. So the idea becomes, can we share that context data through the use of human machine intelligence so that your large language models have the right context to come up with to try to come up with a better response. So we'll showcase these use cases. And we'll start off with the first use case, which is building context-rich data in large language models. Now, as we know here, analysts are humans, and as humans, we all make mistakes. It could be due to several reasons, such as it could be due to lack of contextual awareness. It could be due to skill gaps. It could be stress and fatigue, and more. And here's a great research from Daniel Kahneman in his book Noise, where he suggests that the error is a combination of two things. First is bias, and second is noise. So bias comes when there's lack of context, which is another reason why many times large language models have bias, depending on the data in which it was trained. But humans have bias as well. Second would be noise. Noise comes when we have skill gaps, in which case we're not able to do the tasks accurately in a repetitive fashion. It also comes from stress. This problem is further aggravated due to our current processes. So usually most companies are using, if there is a quality assurance process in the blue team, it could be a random spot check. So maybe a manager could randomly select alerts out of a pool of completed tasks for review. So many times mistakes go undetected till there's a breach or an external audit. Some larger MDRs do have a QA team where they again do random sampling or random selection of tasks. So many times mistakes go undetected. And the whole idea of human machine intelligence is we can actually automate what if we could automate the quality assurance process? And I'll showcase how we are doing this today. So the whole idea here is whenever a task gets closed, can we look at the actions taken by the analyst, and can we try to predict if there's a potential mistake, which can then be reviewed by a manager or team lead or a more experienced analyst to get that feedback and identify mistakes, so that at the end of the day we get accurate processes. And the solution is actually coined by Daniel Kahneman. We came to a similar conclusion years back, where the idea here is, instead instead of looking at the ground truth in cybersecurity, like no one knows, it's hard to understand the ground truth for a process which is new. But the idea here is, can we focus on the process of judgment rather than the outcome to make, and with that approach, can we look for process deviances and identify potential mistakes? And this is something which Daniel Kahneman has already validated. It's in the book Noise, but this is something we have seen on our end as well, where what we can do here is, for instance, for the same kind of task, we can look at historic resolution, like how did different analysts or the same analysts solve this problem for the same client ID over a period of time. What we can do is we can understand the actions taken by analysts and capture the data across all of their tools. In addition, then we can map the inputs and outputs for a specific input, or what was the input that an analyst fed into their tool, and what was the output, and based on that output, what was the subsequent task performed by the analyst. And we can look at these patterns and we can compare them, which enables us to identify deviances from the norm or potential mistake. And this is something we can flag for a review. And the output of this system is as follows, where you can get a like heat map depicting high quality data per analyst, per task, per client, where on the x-axis you have different kinds of attacks, this is something which can be customized. Here we have authentication, email, malware, network related tasks, and more. And on the y-axis we have different analysts, and here we have a heat map where a high score corresponds to a higher quality work along with high quality data, and the converse is true as well, where you have lighter shades. It all means that there's the quality of data is less. So now with this curation, it's easier to identify like what are the data points we should be using to train our large language models, in which case we can get that to that high performance. Now I'll move on to the second use case, which is feeding accurate contextual data into large language models to build playbooks. Now, one of the challenges in the industry today when it comes to automation is identifying what are the accurate processes which can be automated. As I've mentioned, we do have a lot of contextual data. Many times the same attack on one server could be dealt with differently than another. So it's not like you'll get an off-the-shelf playbook which will help us automate everything. That just doesn't work. So the idea becomes, how do we understand what processes can be automated per context? Could be client ID, could be business unit, or specific servers, and more. And this problem is aggravated due to the following reason. Our best analysts usually rely on intuition to solve problems. Imagine you're an analyst, you're looking at a mass load of information, and then you're using your intuition, you're using your contextual knowledge and what you've just seen in the past in order to make some quick judgment calls. So many times by using intuition, the analysts solve problems, but it also means we don't have defined processes many times, because if you ask an analyst, say, what are the exact steps you performed 10 minutes back, it's many times hard for them to address those accurately enough to build a playbook. And what we have seen is the following. By using a technology called process mining, what we can do is we can capture interaction data, but we can mine for accurate processes. What are the repetitive processes which have been QA validated? And we can mine for these processes, and we can present it to an automation engineer, which can help them build playbooks. And with this form of algorithm, you're also able to identify decision bounds. For instance, if a tool gave us certain output, such as an IP address was found in a malicious database, what was the corresponding step taken by analysts? If a tool was not found, if an IP address was not found in a malicious database, what is the corresponding step of actions taken by the analyst? So these are the details which can be drawn from data, which is unfortunately not being captured across all of your tools. But this is definitely something which human machine intelligence is able to do. Now, what we have also done, we have actually conducted a few experiments over the past month, and what we've seen is the following. Once you have these rich process maps, like what are the steps taken by analysts to solve problems, you can do the following. You can actually prompt a tool such as ChatGPT without any form of pre-train or any form of fine-tuning to get some more details around how to build a playbook once you have the process. So what we can do here is, once we have a series of steps, we can use a layer of natural language processing to make it more understandable to a tool such as ChatGPT, and we can feed it and ask it to build automation on Sentinel or on Logic apps. And we do notice some very exciting patterns, that we've validated this approach with one of our MDR partners, and they were very excited where we can ChatGPT. It's not like all these steps would work, but rather it's a good stepping stone in order for an automation engineer to build the automation if they don't have the right experience to do it right, like from a blank slate. So in summary, I've talked about two use cases of how you can use human machine intelligence to further enhance the ability of large language models such as ChatGPT with our contextual data, which in turn helps our humans to become more performant at their tasks. So in summary, I wanted to further emphasize on the notion and the importance of human machine intelligence, where the idea here is AI is not going to automate everything. Rather, we will still require humans in the loop, but then a layer of human machine intelligence would better enable the humans to collaborate with the AI, sharing the right contextual information and the processes required for the AI to, in return, help the humans. So with that, I would like to conclude my presentation, and I'll open the floor for questions.
All right, thank you very much, Tahseen. All right, so I think you can start. Okay, great. Thank you very much, Tahseen. That's a wonderful presentation. And I personally also learned quite a lot from your, as always, learned from your insights. And as I observed, you covered several very interesting use cases, including the ChatGPT, how can they apply, and also some like a very good insights about, I think something I recall is, although the results is important, but the process also very important, right? So how do you map, especially for security analysts, how they are doing things could be a very good input for the AI and to generate better results in the future. And the message you also put in there is, it's not like a one replace the other. It really is a work together. Human, process, machines kind of form a strategy, or kind of like a complement each other to put another defensive strategy. So that's a very great input. I do see some like technical questions related to compare this ChatGPT model with some model. I don't know. You probably know. I guess you can follow up later with whoever asked those questions. One quick question before we go is, you mentioned the SOC actually continues with the Microsoft presentation as well, because a ChatGPT or AI or process mapping can greatly improve the productivity and efficiencies at SOC, right? So what do you see the best approach to implement those kind of like a combining AI and the people to do that?
I think so. That's interesting. We're still at the early stages of like deploying, fully deploying and leveraging tools such as ChatGPT. I can share from my experience. So I think the first step is education. I mean, first, ensuring like our analysts are able to use tools such as ChatGPT. They're actually promoted to use tools such as ChatGPT. I can share an example. I was having a discussion with a colleague where we were trying to build an API integration to provision a certain Azure tool. And without prior knowledge, we just did a search on ChatGPT, and we got pretty strong boilerplate code. I'm assuming 10% of it is wrong, but it still gave us the right information to build out an integration, which would have taken us a week at a bare minimum to build. So the idea here is, first step is to give folks the access to this tool so they can start using it and relying on them. And then the next step here is, okay, how do we feed these AI models with more context-rich data so that you can get a more proper response? So that's how I would look at it, one step at a time.
All right, cool. Education is very important, and people need to get familiar with the power of the tools. Then we could, from there, it's like a form very good iterations. So more people use on that, and so the result also enhance the tool itself. So it's a very good like a cycle about that.